morning student. Today we are going to start carbon and its allotrope. In a previous lecture we have discussed about diamond and graphite. So today we'll talk about some other allotropes of the carbon. Its name is that fullerene. Fullerene is the another crystalline form of carbon. The number of carbon atoms in the molecule can vary from 20 to 900, and you can see that the fullerene structure, it's look like a football, soccer ball. You can see very clear, my dear student. A fullerene is an allotrope of carbon atom whose molecule consists of carbon atom connected by single and double bond. Yes, my dear student, in figure, carbon is attached by single and double bond, so as to form close or partially closed mesh. Yes, my dear student, it may be closed or partially closed mesh with fused ring of 5 to 7 carbon atom. Means especially in your book you will see it is found the shape of pentagonal and hexagonal number of carbon attached in a ring. The molecule may be hollow, sphere or many other shape and size. Yes, my dear student, it is not found in the form of soccer ball, but it may be found in other shape also. You can see the shape of fullerene here. In figure you can see that 5 carbon atom and 6 carbon atom attached in a ring, and you can see that pentagonal and hexagonal structure in the ring of fullerene carbon 60. Now we will talk about the preparation of fullerene. Carbon 60 fullerene can be prepared artificially by vaporize graphite in the presence of helium. Means when vaporized graphite is react with helium and some other equipment, then you can prepare the fullerene in the laboratory. You know, my dear student, the Buckminster fullerene is named on the basis of scientist Buckminster, and he was a scientist. You can see in figure on the basis of his name is given to the allotrope of the carbon 60. Now we will talk about the properties of fullerene. The color of fullerene varies according to the number of carbon atom present in the given molecule of fullerene. We know that the number of carbon is varying from 20 to 900. That's why you can see the different color and different shape also, because it can vary on the basis of number of carbon atom present in the structure of fullerene. It is soluble in many solvent. It is stable and totally unreactive. It is more active than diamond and graphite, and it breaks when it is heated plus minus 1000 degree Celsius. Means at the high temperature it can be broken down. It is a bad conductor of electricity, but some compound of fullerene, when mixed with alkali metal at high temperature, may become superconductor. Means it becomes the good conductor of electricity when it is mixed with the alkali metal at high temperature. Now we will talk about the uses of fullerene. So some uses are given here. You can see very carefully. Use as catalyst, water purification. Cause of it can make superconductor. That's why it is used in lithium and battery and solar cell. Use for the diagnostic agent, or it is used in some cosmetic. You know, fullerene compound is used for treatment of cancer also. Now we will talk about non-crystalline form of carbon. What do you mean by amorphous? The word amorphous meaning lacking in shape and fixed geometry, and carbon atoms are not arranged in order pattern, therefore they do not have any particular shape. Means you can see in figure, the first one is that crystalline form because molecules are properly arranged. But in the case of figure second, you can see that carbon molecules are not properly arranged, they are in random direction. That's why it is called amorphous. There are lots of difference between amorphous and crystalline, but we will know about in higher classes. But just this thing you have to keep it in your mind. In a crystalline form, molecules are arranged in a fixed manner, but in the case of amorphous, molecules are not arranged in fixed manner. That's why they do not have fixed shape and geometry. Now we will talk about charcoal. A porous black solid consisting of amorphous form of carbon obtained as a residue when wood, animal bone or other organic matter is heated in absence of air, then we'll get the black solid substance that is called charcoal. You can see in figure the black solid amorphous substance that is called charcoal, and already we have seen charcoal in our home also. Now we will talk about wood charcoal, and wood charcoal is produced by destructive distillation. And what is a destructive distillation? The destructive distillation, when a substance is heated in absence of air, the process is called destructive distillation. Means heating coal or wood in absence of air at high temperature, it is converted into charcoal. And on heating wood in absence of air, we get as a product coke, coal tar, coal gas and ammonium solution. These are the product we get during the destructive distillation of wood. We will see the destructive distillation in laboratory. We will take the two test tube and both are connected with the bent glass tube, and both mouth is fitted with the cork. You can see that cork is there, and then in test tube 1 we put some wood, and then after heating it in absence of air, you will get the byproduct. And you can see in test tube B, it is filled with the water. Coal tar is settled down at the bottom of test tube B, and also test tube B have a small bent glass tube, and from that tube coal gas is coming out. So these are the product we are getting on the destructive distillation of wood. And what we get the coal and charcoal in this process, it is a pure form of carbon, and after burning it will not produce any harmful gases. That's why by this process we are making the charcoal. That charcoal is used by goldsmith to melt the gold, because charcoal is a pure form of carbon. So my dear student, today we have discussed about the wood charcoal and preparation of wood charcoal. Classes we will discuss about the property of charcoal and its uses. Till then, thank you and have a nice day, my dear student.